Hello guys, welcome back to Burnt Hill Machine. My name is Herb and we have another project. So in the last couple of segments that I've done, I have been building things for from the automotive arena. So I teach at a local college, automotive, and we've had a couple of things pop up that we could use, and I have been machining them on this YouTube channel. So we do have another project. Most of you guys that watch this are familiar with these flexible indicator arms, and they're kind of a love-hate relationship. When they work good. When they don't, they're a pain in the butt. Okay, and we have quite a few of these at the school that we use for doing TIR, for rotor run out, transmission input shaft end play, a lot of different things. And we've used these, myself and you guys have used them in the machine industry. The ones that we have aren't particularly the highest quality. I believe they are all from China. But even the ones that are made that are considered to be a little bit better have their issues. So I'm going to lay this out for you, show you what the problem is, and I came up with a way of fixing it. I thought I had an easier way to do it, and it didn't pan out. So I did come up with another way. It's going to be a little bit more work, but we'll be able to save quite a few of these if it does work, and save the school some money and make a far better product, a higher quality product. Okay, so I got a drawing of what I'm going to do, and I'm going to lay out. I'm going to pull this apart and I'm going to show you exactly what's wrong with this, and then we'll go from there. Okay, so I will see you in another view so that you can see what I'm doing, and in a second. All right, so we're back. Now you can buy these in a couple of different designs as far as how they mount. You can buy these so that they mount on a magnetic base, or you can buy them where they mount on a vice grip style, where you can mount them like this, sideways, either way. And this in the automotive industry makes it pretty universal, because a lot of the stuff we're working on is not a flat surface for a magnetic base. And a lot of it's aluminum. So this works really good if it works. One of the problems we have with these is the way they pin these. If you look at this, everything's always backwards in this camera. They pin this to the vice grip, and it's not really a vice grip style. And although this one's pretty good, they usually tend to rock back and forth. So I figured, well, for that particular problem, we'll just bring it over to the Helioc and we'll just put a couple of spot welds on each side. But this is aluminum, so we're going to have to make another base. That's going to be another project. But that's one of the problems with this thing, the way they pin it. Now, the other problem, the bigger problem, is that when you use one of these on this side, and I've got this taken apart right here, but this slides in and that's where your dial indicator is mounted. Okay, and what's supposed to be able to happen is that I can turn this knob, and this snake or flexible arm gets very rigid, and I can use the dial indicator. Okay, and I can pretty much mount it in any position. Well, it's not necessarily true, because they never really tighten up nice. Okay, when they're brand new, they're not too bad. So what they give you here is an adjustment right here. So I can back this off, and I can adjust this to take all the slack out of the cable that runs down through the center. So if I take all the slack out and I put this in the loose position, take all the slack out, and then I turn the cam, because there's a little cam in here, and you'll see that it's somewhat stiff. It's not real good. And if you look at it really good, you're going to see that this nut is not square to the adjustment screw anymore. And that's because inside here, the first 3 threads are stripped out. Okay? This is made out of aluminum. The nut right here is made out of steel, but this is made out of aluminum. And you always have to bring it right out to the edge in order to try to lock this. If it was up in here and it had a lot more thread engaged with the threads in the nut, it probably wouldn't be that bad. But it's not. Okay? So you can never really get them to lock down nice and tight. Okay. So the first thing one would think is, well, why don't we just put another one of these little spaces in here? I'm going to take this apart and show you why you can't. Because I did machine one shorter so that I could put that in there, but it doesn't work. Okay, so I'm going to disassemble this for you and I'll show you why you cannot do that. So first I have to get this nut back on the adjustment screw, shorten it up, and I already pulled the C-clip off here. So we'll pull this pin out, slide this out, and when you come down here, when this is adjusted to its fullest in this way, so it's got the longest amount of cable stretching out, if you would take this off, and it's really a pain to get it off, but you can't hold it while you're trying to push this down. Alright, we got it. So if you were to put this isn't even a half piece, this is like a third piece on here, you can't get this connector piece to go on. There's just no way to get it on. Okay, so that won't work. Even if we took it down another 100,000, it's not going to work. Okay, so that's out of the question. Take this apart, pull these all off, pull the rod out, and if you pull this screw apart, adjuster, you can see what has actually happened to this. Okay, so basically it's always living out on the end of that adjustment thread, and it just ate the threads right up. Okay, and that's partly because you're always out on the end, and number one, this is aluminum and this one is steel. So what we're going to do is we're going to make one of these. Okay, we're going to make one of these pots. It's not really that complicated, but there are a couple of things that you have to pay attention to for this to work. And the other thing I'm going to do is I'm going to lengthen this. I measured the depth of this, and I can get, I think, almost, I forget what it was, what the measurement was, but I think I could get almost 200 thousandths more length on this. Probably about a quarter of an inch. And I won't be out on the end, and I'm going to make it out of steel. So I think it's going to work pretty good. All right, so we're going to give it a shot. So let me bring the picture over here. And this is what we are going to make. Hopefully this is focused because I'm looking at this little thing on the camera. All right, let me put my glasses on. I'll get right back. All right, so these are our dimensions. The only thing that's really critical here is this hole that comes in from the back side. So if you look at this nut, there's a hole drilled in where this cable sits. And if you drill it too close to this end, you're going to essentially make this longer out this side, and it's not going to work. So we could make this longer. We could try to, make that hole a little shallower, but we run into the area right here where the dial indicator mount goes, so there's really not a lot of room there. The other thing I'm going to do is, this was made for mass production, so inside there it sits on a flat bottom, and this has to be able to go in there. Well, it's huge, the hole. It's really, really big. So I'm going to make that hole just a little bit bigger than this, and I'm going to give it a lot more seat for this to sit on, because I had to file this up a little bit, clean it, because it did start rounding this over as it starts to pull it through the hole, and that's what happens when it wears. So when it's brand new, it's sitting back here, and as that starts to pull that piece of metal through the aluminum and they both start to wear, it goes further and further out, and next thing you know, you're sitting on the edge and it's winding the thread off. Okay, so we're going to make a metal one. This is our piece. It's going to be made out of 625 diameter 12L14. I have a stick of that here, and I'm going to thread this with a die. It is a kind of oddball thread. It is a M10 by 1. Now, I did not have an M10 by 1 die, and threading on a older lathe like I have is kind of a pain in the butt, because you have to set it up for metric threads, and you can't disengage exactly the same way you would do a standard thread. So I did find a die on Amazon for about $8. So we're going to see what an $8 thread, $8 die can do. I got to make about 5 of these, so if it makes 5, I'll be happy. Number one, I'm doing this for nothing. I'm, trying to help the school out, and I really didn't want. I looked around for like a Cleveland die. I couldn't find anything used this size, and something new was going to be rather expensive. So to just give it a test run to see if this is going to work, yeah, $8 is okay. I'm willing to go there. And if I can get a few more out of it, I'll be happy. All right, so we'll give that a shot. But that's what we're going to make. We got 2 drawings here. This drawing right here is where the indicator holder itself sits in. It's got an 82 degree, like a countersink in there. We're just going to countersink that till it matches. But we got a couple of bores to do. We got to thread it, hole all the way through, and hopefully it'll come out pretty good. Okay. And again, I took all the dimensions for this off of the original, and it's pretty sloppy. I tightened everything up really, really tight. So I'm going to try and hold like a plus or minus 5, which shouldn't be any problem at all. Where the dimensions on this, the mating pots, they're much bigger than that. Okay, so we're going to try to make it as tight as possible, make it out of steel, give us a little more length, and hopefully we have a far better product. Other than that, they actually work pretty good if we can get enough tightness on that flexible arm. They work pretty good. So the next time I see you, we'll be over at the lathe. I'm going to throw the forge jar on. I'll true it up, and we'll start turning this. Okay? All right, I will see you at the lathe. All right, so we're set up on the lathe and the forge jar. It's indicated pretty good for a piece of bar stock. All right. So the first thing we got to do is we're going to face off the end, and we're going to come over 1 inch 148 thousandths. If we went a little bit too far, we can clean this end off. Not a big deal, but that's roughly where we want to stay. Okay, so we'll face it off, come in, make a mark, turn this down to 387, which is the outside diameter for the 10 millimeter by 1, and we'll thread it. got 6 left. All right, we're right on the money. Now you can see that's considerably longer than the original piece. Now this has a little bit of a taper on it, but we really don't need that because it just goes up against something square. But I don't know. Yeah, I'm not going to worry about it. I can always put it in later, but I don't think it's going to be a problem. That should be enough. All right, now I'm going to set up, put my tailstock die holder in, and we'll thread this and see what happens. See if that Chinese die can handle this. All right, we got a bit of a conundrum here. So what I was going to do was use, I got about 6 or 7 of these, all different sizes. Use one of these button die holders and put this button die in there and send it home. One thing I did not consider, and probably because I am not used to working with a lot of metric dies, this is not a 1-inch die, which I thought it was. It's a 30mm, and I do not have a holder to hold that, and I really don't want to make a holder before I make this, just to see if this is going to work. So we got to come up with a plan. So I do have a couple of these style small chucks, which I was always going to put a tailstock end on, a number 3 Morse taper, but I didn't. So I think what I'm going to try, and I don't know if this is going to work, is this is not a split die. It looks like they were going to make it a split die, and they didn't, but I'm going to try and hold it in here. I'm going to push it up against the work. I'm going to put the tailstock center in there to put a little pressure on it, and I'm going to use a wrench to turn it. I can't even use a hand die stock because I don't even have one of those that fits this thing. I do have metric dies, and they are all 1 or 1.5 inch outside diameter. So I mean, it came off of Amazon, so who knows what. I don't know if this is standard. Again, I don't use these a lot, so I don't know. So we're gonna give that a shot. We'll see if this works and this tool works, then I will make a tailstock holder. I'll research this a little bit more, find out if 30 millimeter is something common for metric dies, and I'll make a tailstock button die holder for it. But I really don't want to do all that now. So I'll bring you back when I'm all set up with this janky setup, and we'll go from there. All right, we're about as set up as we're going to get. So kill that, double kill it, and let's give it a shot, see what happens. We're all lubed up. All right, I'll bring you back when it's all cleaned up and we'll test fit it. All right. So I ran a tap down through there just to clean it up. I'll put this on here. And it doesn't go all the way. Okay, we're right into about here, right? So I made this a little longer because I was trying to get absolute most I could possibly get out of it. So what we're going to do is we're going to take a little off the end, put a little chamfer on it so we can get it to butt up against there. So if we measure this right now, about 162 long. So I can take 160 off the end and I can make this butt up against it. Alright, I set up a stop to 165 and we're just going to trim this down. And it fits up tight, so that should be good. All right, so let's do the next step. So what I got to do is I have to cut this off so that I can bring it over to the Bridgeport, and I have to mill that flat. Well, actually, before I do that, what am I thinking? I got to drill the hole. So we got to go through the hole through here. Then we'll cut it off, flip it over, drill this hole, and then we will bring it over to the Bridgeport and mill the rest of it. Okay? All right, I'll bring you back when I'm set up to drill. All right, so we fitted that and it came out really, really nice. It's a little shorter than I was hoping for, but it's still well over 200 thousandths longer than the original one, so it should be fine. I adjusted the print so that if this works, I will remember exactly what size to make it, and I won't have to fit it to what it is, although they could be a little bit different. But so I just adjusted the size. So what we're going to do now is we're going to center the hole, and then we're going to drill a 200, roughly 200 thousandths, 201 thousandths, number 7 drill up at least this far, and that's where the cable's going to go through. Alright, I'm going to put some marker on the face of this. I'm going to come up and just touch it. And then I'm going to use my 2-inch Starrett, and I'm going to move over 1-inch 894. I'll go a little bit more so when I put it back in I can face it and put a chamfer on it, get a nice clean edge. So we're going to continue on this project, try to finish it up today. But today is Sunday, and they have a flea market every Sunday up the road from where I live. And I went up there and I found a couple of things that were pretty cool. So I ran across this machinist vise. It's a little bit rusty, $4, but in pretty good shape overall. We'll clean that up and it'll look good as new. And I bought a few C-clamps, some Cincinnati C-clamps. Always can find those, they're $1 a piece. But I was fishing through this box of wrenches, rusted old wrenches. Some of them pretty good brand names, Bonnie and stuff like that, but nothing I really needed. And I came across this in the bottom of it. So I put the end on it, the tip. But it was frozen up solid. It's got a broken crystal. I put some WD-40 in it, and I can get it to move, but it doesn't return. Okay, it kind of stays wherever you put it. So it's in overall pretty good shape. It's not really that bad. It's got a couple of little rust marks on it, but really not that bad. So I'm going to send this out to MR Tool and see what he can do with it, and maybe we'll see it in the next another episode, what it looks like when he comes back. And if you look at any of my previous episodes, I actually sent some tools out to MR Tool Repair, and Mark does an amazing job. So I'm going to ship this out probably this week, and eagerly waiting for it to come back. But back to the project. So we've been making some adjustments on this as we go along. The blueprint obviously was made by me, and when I made this, I wanted this threaded area a little bit longer than what I have right now. It is longer than the original, okay? It is quite a bit longer, especially if you count right to where it back seats right here. I didn't put this taper in here. I don't think I'm going to need it, but it is quite a bit longer. But I couldn't make it as long as I wanted to. So I lost a little bit on there, but I'm only trying, I really only need like 2 or 3, maybe 4 threads. But thinking about it, this cable is going to slide down through there, and this end that's swedged on is going to sit right up against that flat bottom right there. Okay, this is 834 deep. That's what it is on the other one, on the original. I'm trying to gain real estate on this cable enough to try to shorten the cable effectively, but enough room to be able to assemble the component. So what I think I'm going to do is I'm going to try and grab another 20 thousandths or so on this, just a little bit more, maybe even 50. I think I could probably grab 50, and I just got to make sure I don't interfere with this hole where the stuff went through it. If I had realized in the beginning that I wasn't going to be able to get the length I wanted here, I would have made this body longer and just put this hole down here, because this really doesn't matter. This is where the indicator slides through. It really doesn't matter how long it is, just as long as it's not obnoxiously long. So I think I'm going to knock 50 off that and see if I can grab a little more length on this to tighten it up a little bit. And the nice part about this is I can put this together before I finish this, and I can actually, if I don't have enough room to assemble the whole unit, I can put it back in the lathe and I can drill it a little bit deeper. Okay, so it's going to be like a custom fit. We're going to try and figure out, kind of like when we made the threads and we put the adjustment nut on, we kind of made it to fit. So we're going to do the same thing. Okay, right now this is about 10 thousandths long. I'm going to come in here and I'm just going to touch this and face it. I'm going to leave it a little bit longer. It's not a big deal. I'll probably take skim 5 off. I'll be well within my tolerance that I set for myself. And then we're going to come in here and we're going to drill this 250 thousandths, and we're going to bring it in minus 50 thousandths on that depth. For the next step, we're going to put it in the Bridgeport. We're going to cut this flat right here. It's about 69 thousandths we're going to have to take off it. Then we're going to flip it over. We're going to locate on this flat. We're going to come in, we're going to drill this hole all the way through, which is 238 thousandths, which is a letter B drill. And then we're going to come in with an 82-degree chamfering tool, and we're going to chamfer that to fit the mating pot that's going to go in it. Okay? Okay, so you got to screw that all the way up. All right. Now we take this piece right here. Let me zoom that in a little bit. So this piece goes on in here. And this is where it can be tricky to slide it on because you don't have a lot of room in here to make that rotation. I probably could have gained maybe another 50 thousandths, but it's going to work the way it is. So that goes on like that, gets snug in there. This goes on over this. And then this cam feature, that slides on over that, and this cammed feature, this little arm goes down inside here. And that's what does the lock. All right, so that's locked into place. Hey, thanks for watching. Hope to see you on my next video, and keep like and subscribing because the channel is getting close to 300 now. So see you next time. Thanks.